Take the third one. Here the roller is situated on the horizontal surface. It is tied with the AC bar. Okay, it is given. Now here we are applying horizontal force for taking the bar in this direction. P is the force. Now here the roller weight is given, it is W. It is acting downward at the center. B is the contact point on the horizontal surface to the roller. Okay, and this AC rod is making alpha angle with the horizontal. Here what we have to find? S is tension in AC bar. We need to find S value. Okay, tension in this AC bar. Okay, and then RB, reaction at the B point. Now here how many forces are there? One is the weight of the force, first force. This is the second force. Reaction at B point, third force, and tension in this rod AC. 4 forces are there. Okay, first mark the forces. Free body diagram. Free body diagram is removing all the contact surfaces and just taking the reactions by using those contact points. Now see, first mark C here. Weight of the roller is W. It is given. So I have marked here W. And then P force horizontally. Okay, it is horizontal with vertical. It is making 90 degrees. And then reaction at B point. Surface is horizontal. Reaction is upward 90 degrees with the RB. So this RB I took in upward direction through center. Okay. And then this is RB. And then tension I took in this direction. Yes. Okay, I am assuming the direction is like this. We can assume in any direction. According to the answer, we can keep the direction. Initially, I am keeping in this direction. This is making how much angle with horizontal? Alpha. Okay, so here I took the S value like this. And with horizontal, how much it is making? Alpha angle. So I have marked it here. So how the angle will come? If you think, just do the horizontal line here. Okay, and these two are the parallel lines. This is the making some angle with this. In this parallel lines, whatever this angle, so that this angle is also alpha. Okay, so I took that angle, alpha angle. S is making. Now how many forces are there? 1, 2, 3, 4 forces are there. We can't apply Lami's theorem. Lami's theorem is only for 3 forces. So just do the resolution of force diagram. In resolution of force diagram, we are not taking the inclined forces. Instead of that, we are taking horizontal forces and vertical forces only. So here, what is the first horizontal force? P. Okay. Here, RB is in upward direction. In downward direction, weight I took. And here, for inclined component, inclined force, there are 2 components. As we know, horizontal is in this direction. Vertical for this force is in downward direction because it is in the third cube. In third cube, horizontal is in this direction, vertical is in this direction. How much value for this? So for that we can apply the triangular law. So this is horizontal component, this is the vertical component. So if you are applying cos alpha, we will get this value. Yes, cos alpha. In the previous videos also I told, for horizontal take S cos alpha. For vertical, whatever value is coming, we can mark here. It is S sin alpha. Okay. So same thing I have marked S cos alpha in this direction. S sin alpha here I have marked. Okay. This diagram is called resolution of forces. Means only instead of inclined forces we are taking only horizontal forces and vertical forces. Okay. So here after that apply the equilibrium condition for the concurrent forces. All forces are acting at C point center. For keeping the equilibrium of this system of forces, concurrent forces, we are applying all in unbalanced forces. Sigma Fh is 0 and sigma F is 0. Okay, it should not move horizontally. Whatever horizontal forces, it should be 0. It should not move up and down. So whatever unbalanced forces vertically, it is 0. Now apply the first condition. Sigma Fh is 0. I am taking in this direction forces, horizontal forces positive. In this direction forces negative. Now in this diagram, what is the horizontal force? Initially P. Okay, it is positive P. Now next component is S cos alpha in this direction minus S cos alpha is equal to 0. Okay, so here we have to apply S value. So let us do P is equal to S cos alpha. Now here we have to find S. S is equal to P by cos alpha. We can write P secant alpha. Okay, 1 by cos means P is as it is secant alpha. Okay, I am keeping in the box because we have to find tension in the AC bar. Okay, so S is equal to, we are getting the answer in terms of P. Okay, P secant alpha. P is the force, horizontal force. It is not given. Keep P is as it is. Next is Next condition is sigma F is 0. Apply that condition. So vertical forces in the upward direction I am taking positive, downward direction I am taking negative. In this diagram, what is the first vertical force? Upward, RB. Okay, downward forces are W and then S sin alpha. For RB positive, for these two forces negative. Now consider here, for this sigma F is 0, RB is upward, positive, okay, minus W because it is downward, minus S sin alpha is equal to 0. Now RB is equal to W, these two terms will go that side, W plus S sin alpha. Now yes, we can substitute by using this equation. So what I am doing, W I am keeping as it is, plus S means, so I can write P by cos alpha also into sin alpha. So here sin alpha by cos alpha means tan alpha. So next is W plus P into sin by cos means tan alpha. So these two are the required answers. B is the reaction at the contact point B, okay, or B it is, and then S is tension in the rod. These two values we got, S and RB. Okay, this is the solution for the given diagram.